So, hello everyone. Welcome to the August edition of the Software Developer Thursday 2024. As usual, we try to have the Software Developer Thursday talks associated to our specialization strategy in field digital, which foresees three main pillars: IoT, Open Data Hub, and AI. Today the topic will be more AI related, since Marco Perini of Europe. Thank you, Marco, for your availability. We'll present how to use ScrapeAI to do web scraping in generative AI. So, Marco, I won't steal you much more time.
Okay.
The floor is yours, and thank you for coming.
Thank you. Everyone, can you hear me? Yes. So let's move to the slides. Okay. First of all, thank you for coming today. Today I will talk about the ScrapeGraphAI, which is an open source Python library that we've been developing for the past few months, and I gained a little bit of popularity, let's say, on GitHub and also social media, because it was one of the first one that did what it does, what it does, and right now I will show you. So, I will start with the team. So Marco Vinciguerra, Lorenzo Padoan, and myself. We are all master students, and me and Lorenzo graduated, and while Marco Vinciguerra is still graduating yet, probably in I don't know, in December we graduate. Last month we also co-found the ScrapeGraphAI Inc. So this is not just an open source project, but it's also a company, a startup. And I also work here in Noetech Park as a junior researcher in RX research, mainly developing algorithms that apply generative AI to buildings. So find some way to describe buildings using generative AI. So let's say maybe a building can have different floors, each floor can have some offices, each office can have some sensors, and through just a textual prompt, we'll be able to generate a structure of the building, let's say, and also some other interesting stuff. So yeah. So right now, big data is almost like a trend. We know that data is really valuable nowadays, that because you can do a lot of stuff with it. You can do analytics, you can understand what people likes or not in internet, or like try to create some recommendation system, for example, both for products and shops. For example, Amazon uses some really good recommendation systems for recommend products to the users. Also, data is really useful for large language models. For example, ChatGPT is like it's seen like a breakthrough in every field basically, and it's possible all thanks to data gathered from websites and other sources, and also, of course, we can connect all the dots to create some really deep networks and understand what people like. So always back to recommendation systems. So the main source where you can find this data is internet, a big portion of it. Then a lot of it can also, it's also private, so it's not possible to access to public through public URLs, but it's in private documents. But we will mainly focus on data that we can find on web. And the most common way to extract the data from websites is using a scraper, which is basically a tool that allows to extract information from websites and convert them in structured data, for example, XML, CSV files, spreadsheets, TXT. So it's possible to then reuse them later on. And it's becoming, and it's already become a trend nowadays to create smarter and faster scraping pipelines and scrapers, so that people can easily extract data from public sources online. So these are common scraping tools that don't use AI to scrape content from websites. For example, DevTools, which are Beautiful Soup, Scrapey, or web services, for example, Web Scraper Octoparse, that allows you to specify which information you want from the website. For example, outline what you want with the mouse, or click the exact information that you want. And they are really good if the structure or content of the website doesn't change over time. So if it's static, they're really good tools, these ones. But as soon as the content changes or the structure changes, it's difficult to keep up with the new changes. And that's why here it's useful to use large language models to analyze the website structure, to see what are the changes, whether there have been some changes, and need to maybe recreate from zero some scraping pipelines of our code, for example. Yeah, I don't know what, do you code in JavaScript, Python, or Python, JavaScript, or no? A little bit, yes. Okay, well, you know that if you want to script some content from a website, you need to create code your own script, and if the structure of the website changes, you need to change your script, basically. So yeah, it would be convenient to have some way to how to update the script whenever the website change. So that's why was our question, if it was possible to scrape website without any knowledge of HTML, so the language that's being used for describing building websites, and just by writing what you want and how you want it. So with LLM is possible, and also with ScrapeGraphAI, that's the open source library that we've been developing for the past few months, like 3 months. And what it is, it's basically a Python library. It's open source. It uses LLM to understand the structure of the websites, and it is highly modular. So there are different modules that you can use or you don't use based on your needs. So why ScrapeGraphAI? Scrape, of course, because extract information from the web, and graph because, as I was saying before, like it's highly modular. You can connect and disconnect some nodes, which are, you can see them as functions, that each node does a specific function, basically. And so you can create your own custom scraping pipeline to scrape. And AI, because it uses LLM to analyze the website structure and the content of it. If it changes, it can understand if only the content has changed, or the structure of the website has changed. And yeah, so this is the traditional workflow. You need to find CSS selectors inside the HTML, and you need to write your scripting scripts in Python, JavaScript, which coding language you like, and then you start scraping, and then cross fingers, and let's hope that the day after it will still work. And yeah, it doesn't adapt to web structure changes, and also you need to code different script, modify your script over time, both if the structure changes or also for different websites. So what we wanted at the beginning was some sort of way to be really make it easy to scrape. So just by inputting like the URL of the website, the information you want to get from the website, so like in text, and then just start scraping and get the answer in a good structured way, to then be saved maybe in a CSV file or spreadsheets or JSON and so on. So it adapts to website structure changes, corrects itself, until it succeeds, and also flexibility in scraping different websites, because you don't need to write the script again from scratch, but you just need to change the URL, and it will adapt on its own. So these are the available large language models that the library uses, which are from Azure, OpenAI ones, and AWS, Grok, Gemini, I don't know if you know some of them. Also, Olama is like a a provider of large language models that don't need to use internet to use, let's say. You can just run your large language models on your computer or your laptop and make the scraping by yourself, so without any use of OpenAI or ChatGPT, let's say. So you don't need to connect to their services. Of course, it's lower, it's up to the performance specification of your computer, but it's good. So you can use all of these models in a really easy way. So this is the start history of the project, of the GitHub repo. And we can see that there's been like a really steep curve, because basically LangChain, which is a framework that is used for using large language models in an easy way, like shared, made a post on LinkedIn, basically, sharing our library. And before like the post, we had like 100 stars. And after the post, I mean, now after 2 months, we have over 13,000 stars on GitHub. It's being shared a lot. So this was the the post that's shared, and had let me see. Okay, had 3,000 likes and so on, which was really nice. And also, I tried to come up with some, I don't know, some things that I think that contributed to the LangChain, like sharing the library. So I think it was, I mean, before that post, we had already a Python library with the documentation page, so that people can use it really easy and quickly. And we had also set up a LinkedIn and Twitter page for updates, and if there were some updates in the version of the library. We have Discord for the developers and people that wanted to use the library, so that can get into Discord and then talk with us directly. And also we had participated to some hackathons using the library, and we used trendy technologies, so LangChain, for example, and we were actively maintaining the project. Then here I didn't add, but also because it was like a need that many people had. So yeah, I get information from a website in a really easy way without knowing how to code, and it's still a need, let's say. So I think these are the main contributions to why LangChain decided to share the project. And after that, we've been featuring many websites and like newsletter, for example, Hacker News, LangChain itself, Medium. People like started writing posts about us, or like making YouTube videos, and yeah, it was nice. A lot of people contacted us and also started contributing to the library, most of the time through Discord. So they just joined the Discord channel and say, okay, I need this new feature. Can I implement it, or do you have it on the roadmap? So it was really nice. And yeah, this also contributed to make it known to other people, like around internet. And yeah, these are some stats. And after 4 months, we had 13,000 stars on GitHub, more than 1,000 forks, 150,000 plus downloads on Pipey. So basically, people who downloaded the library and installed it on their laptops, and more than 500 users on Discord, plus other users on social media. So these are all the contributors, let's say, of the GitHub repository. So yeah, if you want to contribute, it will appear here, basically. Yeah, so let's get into the more technical specifications. So this is the main overview of how the library works, what it does, basically. The most common pipeline is this one, where you just need to input source. So for example, a URL, but you can also input some documents, so not only URLs. And also a prompt written like this, for example, list me what's inside the page, URLs, and provide a summary. And also the library will process that and provide an structured data format. For example, with the content, URLs, there's an array and summary. There are different types of scraping pipelines available. I mean, you can create your own, but we provide some default scraping pipelines, which to make easier to people to use it. the most common one is called the Smart Scraper, which I will explain later what it does, but basically it's this one. So just take a URL and a prompt and you provide some data. But there are different ones, for example, search, which don't need to have a URL, but just a prompt, and it will like look on the web, where make a Google search to find the most interesting results, and then scrape those results. So it will go like inside the websites and find information. Speech will convert the extracted data into audio file. If you want, I don't know, a summary of some websites, could be interesting maybe for generate some summary audio for news. For example, the news that, I mean, Echo Dot from Amazon already does, maybe something like that, but it's really specific for some website. Maybe with this one you could create your own audio newsletter with wherever website you like, and also other scripting pipelines. For example, Script Creator creates a Python, gives in output a Python script for scripting the website over time, and some others which instead of having to have the URL, you can pass a PDF or a CSV and a JSON. So right now it's more specific for web scraping, but you can also scrape local documents, let's say. So these are the main nodes. As I was saying before, like scraping pipelines are a collection of nodes, and these are the most common ones. For example, fetch, that takes as input a URL and gives you back the HTML from that page. So that HTML can be passed to the parse node, for example. It will get only if you remove any unnecessary stuff from the HTML, and drag generative answer uses large language models to analyze each page and return an answer. And then there are some others, for example, robots, that analyze the robots.txt, which is a file that most of the website have, and tells which page inside the website that you can scrape, basically. And yeah, it's useful, and some others. So for example, text-to-speech, convert the text into audio, for example. And also image to text, it takes as input the URL of an image, and describe the image. So if there is a house, it will say this is a house with some windows. So these nodes can be used inside the graphs. So these are the common graphs. So Smart Scraper, as I was saying before, this is a one-page scraper, and Search Graph, multi-page search engine scraper, and Script Creator, Generative Python script. OmniScraper, these basically scrape one page, but also describe images inside the page. And the Speech Graph generate an audio answer. So for example, the Smart Scraper, this is the collection of nodes used for the Smart Scraper. So it takes as input the URL or a local file containing HTML and a user prompt. Then it will go through the fetch node, parse node, and generative answer node, and give as output a JSON, basically. So for example, if you wanted to this is the Wired science section of the Wired.com website. If you wanted to get all the titles and the description of this website, you could ask, for example, give the URL of this website and ask, give me all the titles and description of each article with the author, and yeah, so it's that easy. So this is the search graph. So yeah, it takes a user prompt. It has a node which is called the search internet. So it will refactor the prompt of the user to make a search query on Google, basically, and takes the top N results and run iteratively a lot of Smart Scraper instances, and then generate the JSON answer. So yeah, the example is because I'm from Kyoto, so that's why I put this. But basically, if you look for typical foods, yeah, from Kyoto, you will get these two results, and these graph will look into each one of the website and get information out of it. This is then the speech graph, so it's basically a node after Smart Scraper and converts the output into audio file, so you get both the structured output and the audio file. Yeah, for example, like this, if you want to get the recipe like spoken out loud, you can use this one. And yeah, we also, you can, as I was saying before, you can input the URL of the website and a prompt where you can specify what you want as output, but you can also specify how you want your output to be structured. So let's say this is specifically for Python, but you can do it also for in JavaScript. Maybe it's called, there's a library called Zot, I don't know, probably. And basically, if you this is by code. If you, for example, if you want a list of news and each news you want to have a title and description, this is the common way to describe this the output using Pydantic in Python. So you could do like this, and then this is the common way to use a graph. So Smart Scraper receive a prompt, a source, and a schema. And this schema can be a list of news, which will be a list of news that contains the title description. By having this, if you have never seen Python, maybe it looks difficult, I don't know. But we also have a way to convert the textual prompt from the user into this kind of code, so you don't need to do this. But if you want to have more freedom, you can specify like this, and the output would be something like that. So an array of news with each news keeps the same structure. You can also have specified it in the prompt. So for example, list me all the AI-related news with the description and put them in a dictionary with the title and description for each one. But sometimes it doesn't work, so it's better to force this. Okay. So let's say let's see some comparative results against like normal libraries. So let's suppose we want to scrape data from wire.com. This is the website. This is the Python script that you need to write using Beautiful Soup. And of course, if the website structure changes over time, you need to modify again this code. While to the right, there's a ScrapeGraphAI, how we use it, and basically it just stays like that. If you want to change website, you need to just change the source, and yeah, you need to specify a graph configuration, which where you can input the name of the large language models you want to use. For example, if you want to use GPT-4 or GPT-3.5, you can just put it in the graph configuration. And if you want to change it, you just need to change one line, and it will use another large language models. Yeah, this is it. So pros are that low code and fast implementation, fault tolerant, to dynamic HTML code if it changes over time. You can run local large language models. It's portable, and we have an open source community that keeps answering to questions on Discord and also GitHub. These are some speed benchmarks with the prompt list me all the news with the description, both from ansa.it and wire.com. And we can see the first one, the model. So for example, the first one is running a MacBook 14 inches and one Pro. So using local models, so without needing to pay. It took 16 seconds to scrape ansa.it. But if you use API-based services like GPT 3.5 or GPT-4 or GPT-4o, it gets even less than that. And right now also with GPT-4o mini, it's even cheaper and faster. And the output is not bad, let's say. And also Grok is really fast. Okay, from the LangChain post that I showed before, like a lot of companies and people also started to contact us, like to make some integrations. One of these is DugWorks, which is developing an open source library for tracking, let's say, logging what an LLM does inside a pipeline. And we're in contact with them, and they integrated this solution into ScrapeGraphAI. This is an example that shows dynamically and visually what's happening inside a scraping pipeline. So you can see, you can also debug what's inside each node, and I mean, it is really cool, and we keep using it. Yeah, these are the repositories where you can find the library. ScrapeGraphAI, which is inside ScrapeGraphAI organization, and also there are two documentations at docs.scapegraphai.com and the other one on the read the docs. And also, of course, if you want to, you can leave a stars on GitHub. And this is the roadmap, so that people that want to contribute for the library, they can follow this roadmap. Right now, we are working towards creating a deep search graph, so it crawls inside the website to find information you want, and in an efficient way, because we can do it in a lot of not efficient ways, but we still need to work on this. For example, a way is to analyze the structure of the website itself. Maybe like this, for example, is wire.com, and we can see there are some patterns that repeat themselves over time, and because basically most of the articles have the same structure, so it would be really easy to, convenient to detect only one structure and then repeat over time the scraping. Page caching, if you want to scrape the same page over time, maybe with different prompts, so you can cache the page and just ask questions to it. Screenshot scraping, so take screenshots of the whole website, and then understand maybe some features of the website, so the structure, maybe if you detect that it is an e-commerce website, so it's really well structured. I mean, maybe it's more convenient to generate the Python script for scraping the websites instead of just giving the whole HTML to the large language models. Whether if it's, for example, a company website which is really highly unstructured and doesn't have tables on it, maybe you can just give the HTML to the LLM with some modification, it will work. So screenshot scraping, captcha solving, this is partially solved in the service we are building, and also adding new web drivers. For example, right now we're using Playwright. I don't know if you know it, which is an open source project for, let's say, get HTML from website using development by Microsoft, but we are also planning to implement other web drivers such as Selenium and others. So yeah, it's in the roadmap. We also, most of the time, we try to make for everyone easy to read the documentation, understand how it is possible to use the library and so on. So what we thought is to fine-tune a small model, a large language models based on so basically we give all the information of our library to an LLM. We train it over our library so that people can ask questions, for example, to ChatGPT, similar to ChatGPT, and get the right information given the updates of the library over time. So if you don't know what's happening, if you don't know what's inside a new release, you can ask to this chatbot basically, and it will answer for you. And we're also developing an API to use the library, and it's already online in api.scapegraphai.com. Basically, we are building a Python client, also a JavaScript one, and a web app for trying out the API. And we're also looking for the adopters to try out the service, the API service. Right now we are giving it out to some we have given it out to some companies to try out and for giving us feedback, and they're already paying for it. So yeah, thank you for your attention. If you want to get access to the API, for example, you can just scan the QR code and yeah, thank you very much. Or contact us on that email. Thank you.
Thank you, Mark, for the nice presentation. Now it's publicum time, question time. Who wants to start?
Ken is already a spider, or is that something that will be in this deep search future point?
You mean to crawl inside our website?
To crawl, yeah.
So right now, so in the API that we've developed, there's the crawling capability. So basically, we call it semantic scraping because it detects based on the URL that are in the web page. It detects which one are more suitable candidates to go inside and look at the information the user wants. So this is called semantic scraper, but in the open source library, there's a similar graph, which is called search link, I think, and it does basically the same stuff, but yeah, a little bit slower, let's say. But it can do that, yes. And an idea could be also to make it really fast. It's to take all the pages in a subdomain of the website. So you have the whole view, whole overview of the website, and understand which are the pages, interesting pages in one go. So yeah, with different techniques that have been developed, let's say.
Yeah, first of all, congratulations. Very interesting project. I didn't know about it. It's really cool.
Thank you.
I have two questions, which are related one to each other maybe. One is which open source license did you choose to release the project? And the second is what is the business model? As far as I understood, you incorporated it now. So what is the business model you are looking for, you are driving?
Okay, so the license, the open source license is MIT. So there was not actually a good reason why we chose it. We saw it as like the most free license there was. I mean, because initially we just started as a hobby, let's say, and we didn't want to get into some awkward licenses, even though right now, I mean, we understand it a little better, and we know there are other open source library that can be used, let's say. But right now it's MIT, and we will keep it like that. I mean, I know that there are some companies that have been built around the open source project that have, for example, for most of the folders inside the library, one license, which is MIT, and then for one specific folder, for example, enterprise, they have a different license for it. So there are companies that maybe ask for some specific feature, and they just put it open source. I mean, they put it in a plain on the repo, but if you want to use it, you need to, of course, stand by the license. So that could be a part also for if there are some companies that want new features, we can implement them and then put them under a different folder with a different license. But right now the business model, it's there are different ways to monetize the project. One is through the API. So let's begin from the start. So from the open source project, we have sponsors. So that gives us some contributions for the whole year or every month, and so that's how we can take some developers to maintain the repo, the project, and so on. So we don't need to, let's say, spend too much money on that because there are sponsors for it, and we're also actively looking for those. And then there is the API. So it's basically the hosted service of the library on our servers, so people don't need to install any Python libraries to use it, but just through a web app. And they can also use the web app or integrate it in their existing code baseline. And the other is we're developing different verticals. So the API would be a more general purpose scraping service. So you can scrape all the pages you want. But there are some customers that want really specific scraping for different scraping pipelines for different sectors. For example, finance. For example, companies outreach or competitor analysis or statistical marketing analysis. So we're planning to we're also doing some verticals specific for those. So, for example, a company wants to get some information related to companies, and we prepare a pipeline and we provide a service for that. So that's the main business model. And then on the long term, let's say creating more domain-specific services. So, for example, you don't need to have a really specific field or mind, but you can, for example, say, give me all the companies in this category of AI, and it will look through the web looking for this. But right now we're mainly focused on open source, general purpose API, and different verticals. So,
thank you. Thank you very much.
Thank you.
Someone else has comments or questions?
Yes, two questions actually. One is I've noticed among the nodes that there's a node that checks the robots.txt, but then it wasn't mentioned in the graphs. So I was wondering whether it's actually always embedded and bolt on as a kind of standard feature, or if it's something that one has to actively choose to respect the indications of the website that is about to be scraped. And the second question, since it's all about AI, it's something I have to ask. How much of the code was kind of the result of AI generation, or just
yeah, so so the robots.txt node is not in the standard pipelines, because I mean it's an open source project and the people can decide to opt or not, let's say, to respect the robots.txt. And but we have we have different examples that use it. So if you want maybe to build a product out of it, you can use those examples. And but yeah, initially we had it in the standard pipelines, and a lot of people complained that every time they were blocked, even though for example in the robots.txt it was not specifically mentioned that it was not possible to scrape some websites, some pages. So we decided to keep it put it optional basically, and one can decide to use it or not. And the other question, let's say, I had already done some open source projects, more like a mechatronics or stuff. So what I did was most of the time when I start like a project, I try to give me use, for example, ChatGPT to give me an overview of how to structure the project. So I like to start with a really structured folders and project directory, and I always use like a object-oriented code. But yeah, like when I needed, I would ask ChatGPT or not. If there were some things that probably he knew better than me, yeah, why not? Yeah. Okay. I can show you if you want a demo. So this is the GitHub, and so that was the example. So the instructions or the README is also translated in many languages. I don't know. Actually, there were like contributors that translated the docs, and I would say that also when they did that, a lot of many Chinese people, Russian people, like started like joining Discord and asking questions. So I think it was effective. And
did they translate it using AI or?
initially, actually, we did it for Chinese, I think. Yeah, we translated ourselves. Then there was like a Chinese guy said, "It's shit. Translation is shit." So I will do it. I will do it myself. So okay. So these are all translated by contributors. So I hope they are correct. I mean, I haven't checked. So and yeah, this is the instruction to quick install it. So for Python, you just need to do pip install ScrapeGraphAI, and then Playwright is the WebDriver used for example, opening the Chrome's instance and get the HTML from it. And this is the most common use, so you can just copy paste this and put it in a script. And what it does is basically you define it imports Smart Scraper, and you can specify the graph configuration. So with, for example, GPT for Omini, if you want to see what's happening under the hood and headers, it will open you can decide if you want to open the browser or not, and it can be useful for rendering some pages with JavaScript if you need so. Then there's the instance of Smart Scraper, and you pass what you want, so find information about what does the company do. The name and contact email, you put the source, so scriptgraphaI.com, and you get as a result a dictionary like this. So company name, contact email. So that's what he found inside the page. These are different pipelines. There's a demo online that we developed for a hackathon. And it's and yeah, documentation like this. The documentation with the library diagram, so on, the LLMs. Yeah, if you want to contribute, just if you want to get in touch with us, just get into Discord channels on LinkedIn or Twitter. And here there's the roadmap that I showed you before, contributors. And if you want to cite us on papers, you can just do this. And yeah, authors, license, acknowledgements. Yeah, this is it. So this is how you can start with it. And so, for example, this was the demo we developed for the hackathon. And you can put it uses OpenAI models. So you need to put the OpenAI key, API key, choose the model, the URL of the page you want to scrape, and a prompt. And also a guy from Amazon developed this, so we added to the demo. And you can decide models hosted on AWS services like Bedrock, and yeah, and yeah, basically does the setup AWS credential, does the same stuff. And for example, this was a demo where you can put for example this URL, for example this one. Let's see. Okay, it's my project portfolio. It's not updated. I mean, there's no ScrapeGraphAI, so it's not updated. Let's say I want to get all the projects inside the page with their title and description. I can just copy paste the URL and like this. Say, give me all the projects and example and description. it will do the scraping. So, yeah. So the project with the name, description, and what's cool about it is that you can also make the LLM like think about something. So if you say, for example, put a score whether you think the project is good or no, you can. I mean, I've never tried it. I just came up with this, but you could do it. Score based on the complexity project. I mean, here it's very generic. I haven't specified any output. Okay. So let's see what it can give me as output. Yeah, I guess it's a score from 0 to 10. So it gave me also a score. 9, there's this, multi-agents, okay. So yeah, you can also think on the scraped data, and you can see the score was not present here. So yeah, it's another thing, added value, and makes it more flexible as respect to the original, traditional, conventional ways. Yeah. Thank you. If you have any other questions. No? Yeah.
Basically, what you just did, you can do with the web GUI of ChatGPT also. You can just point it to a website and say, read it and tell me something about it. I understand that your project has more the purpose of to automate this stuff, right?
Yeah, you can insert.
It's not meant as an interactive chatbot, but rather as you said, a company that uses it to each hour check some website and find if there's something new, right?
Yeah. Then of course ChatGPT creates really good guesses on what to look into the web, on the search engine to look the information you want, but it doesn't actually crawl the whole website. So if you want to,
sometimes does. It depends on when you do it. Sometimes it says I can't open the web page, and sometimes it does. I think they will change it according to some complaints about.
Most of a lot of people call them closed AI for a reason, but it's basically with this you can apply this to your scraping, to your Python script, to your scripts, and it will do the search. Then who knows what GPT-5 or 6 will do? We just we never know. But there's also Perplexity that does web search. But if you try it in really deeply, maybe they have some sort of caching mechanism, and sometimes they are not really up to date. We've done some tests, and while this one, if you decide not to use caching, you will get the most up to date results. And also on the returning to the business model, we also have a database that stores all the information of. If you want to monitor a website, you can store the information of that website on the database, and then keep updating over time, and question that make question to that database and not actually to the real website. Yeah.
I have one more question about the team. So I see there is a lot of work you are doing, a lot of interaction with a huge community, a roadmap, implementing requests, coordinating all this big community. I'm curious how big is the team who is driving the work? Is it still you three, or did you expand? Did you activate some volunteers or paid team members, and if you can give us also some indication about the size of turnover you are doing, so by sponsorship as far as I understand. So I'm a little bit curious now.
Okay, so I mean the founders are these three, and we have two people that are actively maintaining the repo also, and so just by responding to other people requests, issues, or fixing issues, and implementing new features. I mean that are not disruptive. Let's say if there's a feature that is really important and it can collapse everything, then we will. Marco Vinci Guerra is the maintainer of it, and he's also developing the API. And whether Lorenzo right now is creating some really domain-specific application for it, and also developing the API, where myself are doing some demo for clients and go around and look for sponsors and funding. And right now for like with sponsor we get a few thousands, let's say, per month. And but let's say it's not enough to just live with that. So we have a few angel investors, and and that's it. We are also looking for more. But mostly there are two people maintaining the open source library, and another guy that does as an advisor, let's say, with us, which is really good at both scraping and developing solutions, and so it helps us like developing this stuff. And for now it's like this. Of course, we're also looking for still maintainers, contributors, and people. Now for example, right now we're missing the website. I mean, we have a website, but it's not actually that good. We are in contact with like a design studio that does also front-end, back-end. So hopefully this will be a little bit much better, let's say. This is if you want to get in the waiting list for the API, the service, also to get the news on new features that we implement. You can just leave your email, and we will send you some emails, let's say. So we are 6.
Congratulations.
Thank you.
Great.
Where did you incorporate?
In US.
Delaware.
Delaware C Corp. Because it's easier like to get funding from Americans, let's say, and then it's also cheaper, like and cheaper and easier, because for example, they have a service for everything. If you need for example, to have the location of the headquarters of the company in US, there is a service that allows you to do that. If you need to have a phone number, there's a service to do that, and so on. If you want to get paid from US to here, there are other services that allows you to get payroll here, and mostly for the corporation, it costs around 500 euros. Starting. And then, there are some other services around, but like 50 euros per month more. Like this.
Cool. More like 60.
So if you want to open, a company in US, those are more or less the price, the costs.